Hi everyone, this video series is all about SAT math hacks where we discuss smart tricks and strategies to solve SAT math problems. This video is on SAT math hack number 4 where we make use of special products also known as algebraic identities that you would have often seen and used. Here are the 3 most used special products or algebraic identities in the context of SAT math problems. The first one is a plus b whole square, which is a plus b times a plus b, and that can be expanded into a square plus 2ab plus b square. The second one is a minus b whole square, where you replace this plus with a minus here, and that is a minus b times a minus b, and that's equal to a square minus 2ab plus b square. So the only difference between this expression and this expression is that this plus sign here becomes a minus sign here in the cross term. The third one is a plus b times a minus b, and that can be rewritten as a square minus b square. So these are the 3 special products or algebraic identities that are often used in solving SAT math problems. So let's take a look at our first question here, which says if 2x minus 3y is equal to 5, what is the value of this expression here, 4x square minus 12xy plus 9y square. So obviously you don't have to calculate any specific values of x and y. You have to use that expression, that equation 2x minus 3y equal to 5 to calculate the value of this expression. So what do we observe? We look at this 2x here and we note that we have a 4x square here, and we look at 3y here and we note that here we have a 9y square. So that indicates to us that this expression here is perhaps some square, or some related to the square of that original expression on the left side. In fact, 4x square here can be written as 2x whole square, and 9y square can be written as 3y whole square, and then this cross term that we have here, which is minus 12xy, can be written as minus 2 times 2x, this term here, times 3y. So you have this, and now you can see that we have expressed this expression in the form a square minus 2ab plus b square, and that is simply the expanded form of a minus b whole square. So this is nothing but 2x minus 3y whole square, and now our job is done because we already know the value of 2x minus 3y, that is equal to 5. So 2x minus 3y whole square will be equal to 5 square, which is equal to 25. So 25 is our answer in this case. Okay, so that was question number 1. Now let's look at question number 2, which says if a is equal to c plus d, which of the following is equivalent to x square minus c square minus 2cd minus d square. So this expression here looks a bit complicated, but once again you can observe some familiar terms here, c square, 2cd, d square, and perhaps we can combine them in some form and express these terms as a square. So what I'll do here is this x square, I'll write it as x square, but then these 3 terms minus c square minus 2cd minus d square, I'll factor out a minus sign common from all the 3 terms, and then I will write them as c square plus 2cd plus d square. So I've taken out this minus sign and then I've written the 3 terms here all positive, and instantly you can now recognize that this combination of terms is nothing but c plus d whole square. So what we get here is x square minus c plus d whole square, but then we also know that c plus d is equal to a. So this is equal to x square minus a square, and now we can apply the special product for this thing, this expression here, x square minus a square. It can be written as x plus a times x minus a. So let me write this, x plus a times x minus a. So that's our answer, which in among this set is option C. So option C is the correct answer here. Now let's look at question number 3, which says suppose that y to the p square, that is the numerator, divided by y to the q square is equal to y to the 100. Wow! So, this looks like a bit somewhat complicated, but we will just see that it can simplify to something very straightforward. So, y to the p square divided by y to the q square is y to the 100, where y is greater than 1 and p plus q is equal to 4. What is the value of p minus q? So, from this equation here and this value here p plus q equal to 4, it seems a bit complicated or indirect in terms of how do you really find this. But actually, if you simplify this expression or this equation here, if you use the laws of exponents here, you instantly get to the answer. So, let us take a look. Y to the p square divided by y to the q square. Now, you are dividing two terms here that have the same base and two different exponents. So, the same base y in both the exponential terms, and then the exponent here is p square, the exponent here is q square. Now, when you are dividing two exponential terms which have the same base, like a to the m by a to the n, we know that this is simply a to the m minus n. The exponents are simply subtracted. So, in this case, we will have y to the, so this will become y to the p square minus q square. The exponents are subtracted. So, you get y to the p square minus q square is equal to y to the 100. So, now you are comparing two exponential terms that have the same base, which means that the exponents must be equal. So, this means that p square minus q square is equal to 100, and now we apply our special product for p square minus q square, which is p plus q times p minus q. So, p plus q times p minus q is equal to 100 and now we can see why this value here is helpful. P plus q is equal to 4. So, in this expression here we put p plus q equal to 4. So, 4 times p minus q is equal to 100. So, let me write that here. So, 4 times p minus q is equal to 100, and that means that p minus q is 100 divided by 4 or 25. So, the value that we wanted to find, p minus q, that is equal to 25. So, option B is our answer here. The next question, number 4, says which of the following expressions here is equivalent to 16s to the 4 minus 4t square, 16s to the 4 minus 4t square. So, you can see that there is a 4 factor of 4 that you can take out as common, you can factor that out, and you can write this expression as 4 times 4s to the 4 minus t square. And what I am trying to do here is I am trying to factorize this expression so that I get one of these expressions here. So, now you have 4s to the 4 minus t square. So, this 4 times 4s to the 4, I will write this as 2s square and the square of that. So, observe this carefully. I wrote 4s to the 4 as 2s square and the square of that, because if you take the square here, 2 square is 4 and s squared squared is s to the 4. So, I write this as 2s squared minus t square, and now if you look at this expression inside the bracket here, it is of the form a square minus b square, where a is this term here. It has a is 2s square and b is t. So, this expression is of the form, the expression inside the bracket is of the form a square minus b square, and the special product there is a plus b times a minus b. So, I will write this as 4 times a plus b times a minus b, but now this is important, a here is 2s square. So, that is the first term. So, I write 2s square plus b, which is t here, a and a minus b. So, 2s square minus t. So, this is how I can factorize this, and I can observe that that is equal to option C here. So, option C is the correct answer in this case. All right. Now, to question 5, consider the system of equations 1 by 4 t plus 6 plus 1 by 3 u minus 5 is 40, and then the same expression here minus the same expression here is equal to 20, and therefore, what is the value of the product 1 by 4 times t plus 6, 1 by 3 times u minus 5. Now, of course, if you leave the expressions or the equations in this form and you try to deal with them directly, there are a lot of terms here to deal with, but you can instantly see that this term here is the same as this term here, and this term here is the same as this term here. And what you have to find as well is not t and u separately, you have to find this specific product here, which is simply the product of this term and this term. So, if I, let's say, substitute this term as, let's call it a, and I substitute this term here, let's call it b. So, I get a plus b is equal to 40. So, a plus b is equal to 40, and a minus b, remember this is a as well, this is b, a minus b is equal to 20. And what I really have to find is a times b. So, I have to find the value of a b. So, the question has now become really simple. We are given the value of a plus b, which is 40, we are given the value of a minus b, which is 20, and we have to find the value of a b. So, how do we do that? Well, there is a simple trick in this case. What you can do is square both of these equations. So, a plus b is equal to 40. If you square that, so I'll apply a square here, and I'll also apply a square over here, and you will soon see why this is helpful. So, the first equation gives me a square plus 2ab plus b square. Once again, I am using the special product for a plus b times a plus b, which is this expression. This is equal to 40 square or 1600, and the second one gives me a minus b whole square will be a square minus 2ab plus b square, and this is 20 square or 400. And now what I do is, because I want ab and I do not want a square or b square, so what I will do is this equation here and this equation here, I will just subtract them. So, I will just subtract the second equation from the first one. So, if I do that, you can clearly see that the a squares will cancel out, the b squares will cancel out, and you will be left with 2ab minus 2ab, that is 4ab. So, you will have 4ab on the left side is equal to 1600 minus 400, that is 1200, and from here you instantly get ab as 1200 divided by 4, and that is equal to 300. So, 300 is our answer in this case. So, that completes question number 5 and brings us to the end of this video. So, this was SAT math hack number 4. Make use of the 3 special products that we saw, or the 3 algebraic identities which come up very often on the SAT math test. A plus b whole square, which is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and a plus b times a minus b is a square minus b square. So, that was the hack. I hope you liked it. Let me know what you think in the comments.